Alright, modeling with functions. Some terminology here before we get started in problems. Independent variable, all this is, typically that's our x, okay? It's our x. It's what applies with the domain. Dependent variable is typically our y, okay? And it makes sense, dependent. It depends upon what you put in for x for what you get for y. So some terms there to just be aware of. Let's go to the next page here. Function notation. All function notation is, instead of doing y, we do what's called f of x. F of x, okay? So as we're going through here, sometimes you'll see y equals, and then sometimes you'll see f of x equals. They're the same thing. The only reason to use function notation is, I'm going to write this down real quick here. If I do f of 2, all that means is I'm plugging 2 in for x. So I know x is equal to 2, and I plug that into the function or equation. Whereas if I use y equals, I have to state what x is equal to. Whereas in function notation, you can just write that in. Okay. Again, we're going to be dealing with domain and range. So as we're going through some of these problems, you'll want to make sure, be reminded, domain is your x or independent variable. Range is your y or dependent variable. Now, independent and dependent are going to be important to us later on. We're going to do some things called scatter plots, and those terms are going to be important as we continue on. So again, domain and range here for some examples. We're going to go to the homework section here, and we are going to start with problem number 5. Okay, so it says for each situation, identify the independent and dependent variables, write a function in function notation, then use the function to solve the problem. Okay, so let's start with problem 5. Bruce owns a small grocery store and charges $4.75 per pound of produce. If a customer orders 5 pounds of produce, how much does Bruce charge the customer? Okay, so we got to identify our independent and dependent variables. Okay, so how do we do that? Bruce owns a small grocery store and charges $4.75 per pound of produce. Okay, $4.75 per pound. Now, remember earlier in class, I've talked about this word per. Whenever we see it, typically when we want to think of slope. So I'm going to write this down over here. $4.75 per pound. So that is our slope. Slope is rate. Slope is y over x. Now, oops, not a triangle. Sorry about that. An x. Y over x. So this is very important that we get this, because if I go back over here at the beginning, my y-axis is dollars. My x-axis is pounds. Now, why is that important? Because we got through saying a minute ago, independent variable is our domain, which is our x. So our independent variable here is the number of pounds. So number of pounds is our independent variable. So our dependent variable is our top portion, our y, which is the cost. That's our dependent variable. Okay, so we've identified independent and dependent. So a function for this would be, in function notation, f of x equals $4.75 per pound x. So f of x is representing our y, which is our cost. So the cost is based upon how many x or pounds we order or get or buy or whatever. Okay, so for this particular problem, so there's our function notation. There's the identification of our independent and dependent variables. And then it says to solve. So it says if a customer orders 5 pounds of produce, how much does Bruce charge the customer? So in function notation, that would look like this. F of x is 5 here. So what's that mean? I'm going to erase this picture here so I can write over it real quick. Get rid of this so you can see as I'm writing here. So we've got 475 times 5. So all we're doing is we're taking that 5 and we're plugging it in for x. So when we do that, let me get my calculator here. So 475 times 5 is 2375. So be 2375, and that would be in dollars. Okay, let's go down to problem number 11. Actually, next page, sorry. Cindy is buying jackets for her local community's charity auction. Each jacket costs $50. Okay, so right here, each jacket costs $50. Each jacket. So what's that mean? It's $50 per jacket. So there's our slope again. $50 for a jacket. So again, here is our x, which is our independent. Our independent variable here's on the bottom. What's our independent variable? The number of jackets. What's our dependent variable? Our dependent variable is the cost again. Now, that's also going to be important to us as we start graphing later on, because we'll have to label our x and y axis. Okay, so we write function notation again. So f of x equals 50 times x. So depending on how many x jackets we get, will tell us our cost by multiplying by 50. So in this particular problem, it says she bought 23 jackets. So we do f of 23. So that'd be 50 times 23. So again, I get my calculator out. 50 times 23. And that's $1,150. Okay, let's go to problem 13. Write a function using function notation to describe each situation. Find a reasonable domain and range for each function. Okay, so similar, now we're identifying domain and range, so we'll do that as we go through here. I'm going to erase these problems underneath here, so again, I've got more room to write as I do this problem. Elijah has already sold $40 worth of tickets for a local raffle. He has 5 tickets left to sell at $5 per ticket. $5 per ticket. Okay, so again, there's our slope, $5 per ticket. So what's that mean? Our independent variable is tickets. So that's our independent, which is our x. Our dependent is our y, which in here is cost. Okay. So function notation says he's already sold $40 worth of tickets for a local raffle. He has 5 tickets left to sell at $5 per ticket. Okay. So he's got $5 per ticket times the number of tickets he sells, which is x, plus what? Plus 40. Now, why 40? Because he's already sold $40 worth of tickets. And he's selling the remaining tickets, which is x, at $5 per ticket. Okay, so this would be our function notation. You don't have to put that dollar symbol in there if you don't want to. So 5x plus 40. Now it says find a reasonable domain and range. Okay, so our domain is from what? 0 to 5. Now why 5? Because he only has 5 tickets left to sell. Okay, now remember we can't sell a partial ticket, so we would say whole numbers from 0 to 5. Okay, now, what about our range? Well, our range is our y, what we get when we plug in. Now, if we don't sell any more tickets, if we sell 0 more tickets, so if this is 0, this goes away, so how much do we have? We have $40. So no matter what, we've already got $40. But let's say we sell all 5 tickets. So I put 5 in here. What's 5 times 5? 25. 25 plus 40 would be 65. So our range goes from where? It's from 40 to 65. How? In multiples of 5. Now why multiples of 5? Because that is our slope up here, or our rate, $5 per ticket. So no matter what, we already have $40. We can make it as high as 65, but that would only happen if we sell all 5 tickets, so that would be our range. A lot involved here, but it's good stuff. Good things that you need to definitely understand, especially moving forward. All right, let's try problem number 19. So again, I'm going to do the same thing. I'm going to erase the problem underneath here. Give me some more room to write. Okay, Matt has already sold $72 worth of tickets. Now, this is what we're starting with, so I'm going to start referring to that as like our starting point. He has 6 tickets left to sell at $9 per ticket. So there's our slope again. $9 per ticket. Okay, so our function here would be f of x equals our slope times x plus our starting point, what we already have, which is $72. Okay, our domain is our tickets, our x, which goes what? From 0 up to 6, because we have 6 tickets left to sell. So whole numbers from 0 to 6. What about our range? Okay, well, our range is $72. We know we've got that much. But how much can we get up to? Well, it depends. Again, if we sell all 6 tickets, so I'm going to plug 6 in here. 6 times 9 is 54. 54 plus 72 is 126. Okay, so we're going from 72 to 126 in multiples of what? Multiples of 9. Why 9? Because 9 again is our slope back up here. So our slope tells us the multiples in which our range goes from. Now let's do one. Let's look at this problem 21 here. It says the function f of x equals negative 6x plus 11 has a range given by negative 37, negative 25, negative 13, negative 1. Select the domain values of the function from the list. Explain how you arrived at your answer. Okay. So what we're doing here is we're trying to figure out which of these values right here will give us, I don't know why my pen, there we go. Which of these values right here will give us these values. So the way we arrive at that is by just plugging in. Now, I know 1's not really a good choice. And the reason I know that, I'm going to work this out up here. So f of 1 would give me negative 6 times 1 plus 11. Negative 6 plus 11 would be 5. Okay, these are all negative numbers here. So I need to find the values that give me those. So then I just keep going through. So like f of 2, so I try 2. Negative 6 times 2 plus 11, that would be negative 12 plus 11, which is negative 1. Well, that's one of our choices right here. Negative 1. So what gave me negative 1? 2 did. So f of 2 equals negative 1. So there's one in our list. And what I do is I just keep going through and doing those. Well, one thing you can notice here is how did I get from here to here? I went down 6. Now why? Because that is my slope. It's going down 6 every time. So I don't have to work out every equation. What I can do is I know f of 3. So if I plug 3 down, or plug 3 in, this has to go down 6 more, which would take me to negative 7. If I do 4, this goes down 6 more. If I go down 6 more from negative 7, I get negative 13, which is on my list up here. If I do f of 5, I'm going to go down 6 more, which is negative 19. F of 6, that's going to go down 6 more, which is negative 25. Now, you should start seeing a pattern here. So these are the values that are working. What do you notice about all these values in here? They're all even values, or giving me the values that are up here, which are negative 1, negative 13, negative 25. So guess what's going to give me negative 37? The 8. Okay? And remember, I've talked to you over and over again. Math is about two things. Math is about patterns. Math is about doing the same thing in different ways. You're going to start seeing that a whole lot here in this book as we go through this. So for this particular problem, the values that work would be 2, 4, 6, and 8. So hopefully this is giving you some insight into domain, range, function notation, patterns, a lot of stuff in this lesson.